Shanti, Shanti, class. Dhanush, the screen is visible and audible. Dhanush. Rasul, the screen is visible and audible. Rasul.
Screen visible,
yes, sir.
Okay, okay,
Yes.
okay. Good morning, everybody. At the last class, we discussed about three types of electrodes. One is coated with iron oxide and beryllium. Other one is a plain rod or plain bare electrode, and the other one is tubular electrode. In the tubular electrode center, you have the flux. Usually, flux is made of iron oxide, calcium carbonate, manganese oxide, and also cellulose. So these are the materials used as flux and coating on the rod. Three types of coated electrodes are used in welding. So depending upon the application, they employ the coated electrodes. Next, come to the point. What are the functions present in the flux? This is very, very important. Please, all of you write down the functions of flux. Functions of flux. Still, few people are waiting for to join.
ಎಲ್ಲಿ ಅಂತ ಹೊಡ್ಕೊಳ್ಳಿ ಅಂತೀವಿ. ಪಿ ಅಂತ ಏನು ಹೇಳ ಕಲಿತೆ
Last class, we discussed about three types of electrodes. One is coated electrode, other one is a plain or bare electrode, and the third one tubular electrode. The coated electrode, the center you have a mild steel rod, or sometimes which is made of the same type of base metal, whether it is stainless steel. For that, they produce the rod or they use the rod with stainless steel only. Suppose if you are using alloy steel or low carbon steel, the low carbon steel electrodes are available on which you have a coating of the flux. The flux is usually made of iron oxide, mica, calcium carbonate, cellulose, titanium oxide like this. The type of flux is coated on the rod. It depends upon the type of application, because the common flux is used is iron oxide along with beryllium. So that is the flux used in all the rods which is available in the market. Next, a plain bare electrode. So usually this is made of mild steel or alloy steel or copper alloy or aluminum alloy. Next, other one is tubular electrode. You see, in the tubular electrode, in the center, they fill the tube with the flux and covered with the mild steel, low carbon steel, or the copper alloy or aluminum alloy. Usually, this type of rod is used in specific applications. Next, come to the point, the functions of the flux. All of you please write down what are the functions we observe in the flux, and what are the functions are present in the flux. So these are the functions we expect in the flux. First, you write down number 1, prevents oxidation of molten metal. First, you write down the title, functions of flux. Underline that. Below that, write down number 1, prevents the oxidation of molten metal. See, all of you know that the edges of the joint are made to plastic state, that is the liquid state. In that state, the metal has the tendency to react with the atmospheric air. So due to that reaction, the oxide is formed in the joint. So that can be avoided by using the proper type of flux on the coating and which covers the joint with the slag. So that is the main important. So that you can avoid the oxidation of the joint. Next, write down. First, number 1, write down, prevents oxidation of molten metal. Molten metal in the joint. You write down, add a word, in the joint. Next line, write down number 2, helps in removal of oxides. Number 2, helps in removal of oxides and other undesirable substances present on the surface of the workpiece. See, after the solidification process, after cooling of the joint, the slag which is present on the joint is removed by chipping or chipping hammer. So usually they use a chipping hammer to remove the slag on the joint. Next line, right now, number 3. I think all of you have this second, number 2, helps in removal of oxides and other undesirable substances present on the surface of the workpiece. Surface of the workpiece, full stop. Next line, write down number 3, chemically reacts. Next line, write down number 3, chemically reacts with the oxides, and forms a slag, full stop. The slag floats and covers the top portion covers top portions of the molten metal, thereby preventing it from the rapid cooling. See, one thing, remember, if the slag is formed on the joint, thickness of the slag is usually 1.5 millimeter, 2 millimeter, sometimes it is 2.5 millimeter. So that much of slag is present on the joint, which makes the joint to cool slowly because of the heat transfer from the joint to the atmosphere, joint to the side, and the other heat transfer is slowed down because of presence of the slag on the joint. So due to that, the defects like brittleness and crack will not be formed in the joint. So this is very, very important. Chemically reacts with the oxides of the flux. Usually the flux are made of iron oxide, then forms the slag. So the slag makes the joint to cool slowly. Due to that, defects are reduced, which makes the joint strong and reduces the formation of defects like brittleness and cracks. Next, to come to the point, stabilizes the arc. So this is very, very important. See, for continuous joint, you need a continuous arc. So that's nothing but stabilizing the arc. So if the slag is present on the surface and the flux is present on the electrode, which makes the arc to stabilize and fall and directly hit the joint. Next, write down number 4, stabilizes the arc. Next line, write down number 5. Eliminates the weld metal porosity. See, this is very, very important. All of you underline this sentence. Eliminate the weld metal porosity. See, if the joint is leak proof, there is no hole, there is no cavity, then the leak proof joint is important for some applications like containers, tanks, and boiler. You need the leak proof. So this presence of flux on the rod, which reduces the formation of porosity in the welded joint. Next, minimum spatter adjacent to the weld. See, sometimes the disturbance of the portion near to the welded joint always occurs. So that type of spatter is reduced if the presence of flux on the rod, on the filler rod or electrode. So these 6 functions are very, very important. Some question papers, they ask some question paper list the functions of the flux in the electrode. So for that you have to write 6 functions. You write minimum 4 or 5 in the examination. So this is the explanation for plain, bare or uncoated electrode, and this is the explanation for tubular electrode. Next, come to the point, write down electrodes. Next, write down electrodes. Electrodes. Write down few points. A welding electrode. First, you write down the title, electrodes. Underline that. A welding electrode is defined as a component of the welding circuit Write down few points. Definition of electrode. A welding electrode is defined as a component of the welding circuit, through which current is conducted. Current is conducted. In other words, the electrode forms one pole of the electric circuit, while the workpiece forms the other pole. Full stop. Thereby completing the electrical circuit. Full stop. Next paragraph, write down. Welding electrodes are classified into two types. Below that, write down. Number 1, consumable electrodes. Next line, write down. Number 2, non-consumable electrodes. First, all of you listen properly. This is very, very important. Suppose if you go to any manufacturing industry or electrode manufacturing industry or the transformer manufacturing industry, they ask you the question, say, what is the function of electrode and define the electrode. So definition of the electrode is a component of the welding circuit through which the current is supplied, and very, very important, write down all of you, the arc is established. Write down the very, very important point. The arc is established between the electrode and the workpiece. All of you underline the sentence. The arc is established between workpiece and the electrode. Keep Keep this sentence in the inverted commas and underline that. This is very, very important. Put a full stop. See, when you struck the electrode to the workpiece, an arc is established between the workpiece and the electrode. You know that the workpiece and the electrode are very, very important. So electrode becomes one pole and the workpiece become the another pole. So in the DC current, you require minimum two poles. This is very, very important, and thereby completing the electrical circuit, so that you can establish the arc. The arc has the enormous heat and has the temperature of 3000 to 4000 degrees centigrade. That temperature is maximum enough to melt the edges of the workpiece. Workpiece are made by mild steel, cast iron, stainless steel, alloy steel, or low carbon steel. So ferrous and non-ferrous metals both are welded by using using welding process. Next line, write down. Welding electrodes are classified into two types. Remember, in your lifetime, electrodes are classified into two types. Below that, write down number one, consumable electrodes. Next line, write down number two, non-consumable electrodes. Consumable electrodes, and next line, write down number two, non-consumable electrodes. Remember, this is very, very important. In TIG, tungsten inert gas welding, the electrode is to establish the arc, that's all. And the filler rod is along with the electrode. So in that case, the electrode is not consumed in the welding process. It is just produce the arc between the workpiece and the electrode, and the filler rod is used as the filler metal. That's only in TIG welding. In non-consumable electrodes, that is TIG welding. In TIG welding, the electrode is non-consumable. It is not used, only which establish the arc between the workpiece and the electrode. The consumable electrode means, as you are seen in the electric arc welding, gas welding, MIG welding, and submerged arc welding. All the welding process, you use the electrode as the filler metal. But in non-consumable electrodes, only in TIG welding, the tungsten electrode is used. The function of the tungsten electrode in the TIG welding is to establish the arc between the workpiece and the welding rod, tungsten welding rod. In that case, the welding rod is not consumed, not used. So that is non-consumable electrodes. Say, put a hyphen, consumable electrodes, put a hyphen, write down arc welding, electric arc welding, comma, gas welding, comma, MIG welding, etc. In non-consumable electrodes, put a hyphen, TIG welding. TIG welding, comma, laser beam welding, comma, etc. See, two types of electrodes are used in welding. One is consumable, other one is non-consumable electrodes. See, that's the explanation for consumable electrodes and non-consumable electrodes. Next, come to the point, all of you write down welding defects. Underline that. Write down the title, welding defects. Welding defects. Write down welding defects. Underline that. Below that, write down welding involves various parameters such as write down few points. Welding involves various parameters, such as type of workpiece material, electrode material, power source, heat input, cooling rate, welding speed, etc. I repeat, welding involves various parameters such as type of workpiece material, electrode material, power source, heat input, cooling rate, welding speed, etc. See, these parameters, like of first, mild workpiece material, whether it may be stainless steel, mild steel, alloy steel, or any type of steel, if you want to join the type of steel and the type of electrode material and the power source and the heat input used to melt the edges of the workpieces and the cooling rate, welding speed. So these parameters which affect the welding, leads to the formation of defects. What are the defects you observe in welding? First point, brittle. The joint becomes brittle because of the difference in the material, difference in the electrode material, difference in the electrical power input and heat input and the cooling rate, which leads to the formation of cracks, brittleness in the joint. If you properly control the parameters, which may lead to the no defects in the joint. This is very, very important. Control the heat input, cooling rate, and the welding speed. From that, you can avoid the formation of defects in the joint. This is very, very important. Remember the parameters which affect the welding joint or welded joints are the type of workpiece material, electrode material, power source, heat input, cooling rate, welding speed. So these are the parameters which makes the, if there will be a problem in these parameters, which leads to the formation of defects in the joint. For that reason, properly control the parameters so that you can avoid the formation of defects. Next, you write down the common defects in the welded joint. Write down the title. Common defects in the welded joint. Write down the title. Common defects in the welded joint. All of you listen and observe here. Here you have 8 types of defects usually formed in the arc welding and gas welding. Arc welding and gas welding. All of you go through the diagram one by one. First one, crack. See, the crack is formed due to uneven burning of the edges, uneven burning of the edges, and the welding speed, slow and fast welding, and the heat input to the welding, and the type of electrode used in the welding. All these parameters which leads to the formation of crater crack. See, the gap is filled with the excess filler metal that appear like a crater. In that you see the crack in the crater. That the first diagram indicates crack in the welded joint. Next, come to the point, distortion due to heating of the edges. There will be a bending of the workpieces. The joints are formed between the two workpieces. The workpiece are distorted. All of you observe here, the bending of the workpiece takes place. This is nothing but distortion. This is due to the heating of the workpieces below the recrystallization temperature. If you properly not cool the joint in the open air, which leads to the formation of distortion in the workpiece. Next, porosity. See, the porosity is the hole or cavity is formed in the joint. See, all of you observe here, this is the T joint and this is the joint. You can observe the hole in the joint, that's called porosity. Next, undercut due to the melting of the metal. It is not filled with the filler metal which cut the base metal or the workpiece metal, that is called undercut. Next, incomplete penetration. Incomplete penetration due to cooling of the filler metal, due to cooling of the joint slowly or fast. Due to that, there may be an incomplete penetration of filler metal takes place in the joint that leads to the formation of a defect called incomplete penetration. And inclusion, say you cannot produce 100% pure joint or clean joint or perfect joint. There may be some foreign material is always present in the surrounding or in the location which includes, which enters in the joint, which may be a foreign material which is come to the joint. That's called presence of inclusion in the joint. This is also one type of defect. Next, the lack of fusion in the top and the bottom portion of the workpiece. That is a lack of fusion that may take place in the butt joint and T joint. Lack of fusion. There will be a lack of molten metal or lack of filler rod. Due to that, the complete filling of the joint is not takes place, joint takes place, so that there will be a lack of complete filling of the joint takes place, which leads to the formation of defect called lack of fusion. So these are the 8 types of defects are observed in welded joint. Some question paper you have the question on the lack of some question paper you have the welding defects. So write down the question. Write down the question. Explain briefly with neat sketches. Explain briefly with neat sketches the welding defects. The welding defects. Put a question mark. For this, write minimum 5 defects and explain with your own sentence. Minimum 5 defects, explain with your own sentence. Now I stop at this stage. I will continue in the next class. Now all of you please unmute yourself and write your name and USN in the chat box and answer will call. All of you unmute yourself. Please answer roll call. Jishan Ahmad. Answer roll call. Vivekanand.
Present, sir.
Hemant.
Present, sir.
Hemant KS, Dhanush, Vignesh,
Present, sir.
Jitendra, Nikhil Gowda, Prema H,
Yes, sir.
Akshay M. Patil,
Yes, sir.
Nayat Sharif, Adil SU.
Sir, Naya Sharif.
Present, sir.
Okay, Nayat Sharif. Okay. Adil,
Present, sir.
Aishwarya KS, Abhiram HA,
Yes, sir.
Kumaraswamy, Bhairappa Hegde, Harshavardhan, Aditya, Nutan, Lohit Kumar, Harsha MR, Sharath Madik, Mohan Raj, Bhagat HR, Pratik S,
Yes, sir. Yes, sir.
Okay, Dhanush G,
Yes, sir.
Daud Rasool,
Present, sir.
Mohammad Raja,
Present, sir.
Kritik K,
Yes, sir.
Nishchit Gowda,
Present, sir.
Jitendra NS.
Yes, sir.
Anybody else? Please tell me your name.
Sir, Aditya.
Aditya, okay. Next.
MR.
Okay. Next.
Nutan, sir.
Nutan, okay. Next.
Sir, Mohammad Raza.
Mohammad Raza, okay. Next. Now I stop at this stage. I will continue in the next class.
Sir, Hemant KS.
Hemant KS, okay, ma. Next.